Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy. And I'm Jeetendra Dixit. I did my BTech from IIT Kanpur, and I have been mentoring IIT-JEE aspirants for the last 11 years. So I teach mathematics, and today we'll continue functions. We'll discuss range, how to find range of a function. Okay, this is a very important and interesting part also. We use range in we find the range of functions, like trigonometric functions, the range you have done in trigonometry, right? Range of quadratic or some other polynomials we have already done. So now we will find the range of all the functions which are possible without using calculus, all right? Derivatives and all. And then we keep doing this in other chapters also, like AOD. We learn how to find the range using calculus. Calculus means monotonicity, maxima, minima, all right? So that is also there. So it's an ongoing process. Many methods you keep learning in different topics, and most of them we are going to apply here today. So today we'll learn a lot of methods, and then we'll continue doing that in next session also. Let me check my voice first. Yeah, that's perfect. Uh, so as you know, Unacademy is India's largest online learning platform, and you can get plus subscription as well as iconic subscription on Unacademy. So what is plus subscription? If you take IIT-JEE plus subscription, then you get access to daily live classes of your educator. Now you can attend anyone's all the educators who are teaching, who are taking courses on plus. You can attend their live sessions and recorded sessions as well. There's no restriction. So this is the unlimited access you get. So you can follow educators of your choice, okay, or you can join some course. That's up to you. You get unlimited live tests and quizzes going on the plus platform. All these courses are well structured. Well structured means everything is pre-planned, so you can see the schedule of all the upcoming lectures in well advance. And even if you are not having the plus subscription, then you can attend special classes, all right? Special classes for free. Also, all special classes are free, so you can attend unlimited special classes on the platform. Just download the app, make your account, and you can start doing that. So every day, many educators are taking special classes, so you can attend those classes. Like I also take after this class, I'll take doubt class of mathematics at 8:30 p.m. today. All right. So you can attend these special classes. You'll get to know how to interact with the faculty educator, how to send your doubts, how to ask your doubt, how to participate in polls. So this is a very interactive platform. You can just experience it by attending the special classes, and these classes are definitely going to be beneficial. So this is the plus subscription charge, 56,000. Sorry, this is not plus. I'm sorry, iconic subscription. Okay, so let me tell you the iconic these are the plus subscription charges. 38,500 for 1 year. And that too after 10% discount, it is going to be 34,650. For 24 months, it is 566 5600 56,000, sorry. And after 10% discount, you'll have to pay 50,400. All right. Iconic subscription. This is another new feature we have added, iconic subscription. So what is iconic subscription? You get all the benefits of plus which I've just told you, all right, in iconic subscription. So you'll get everything what you were getting in plus subscription. Apart from that, you'll get a personal coach who will guide you throughout your preparation for all the top exams, all right, in a personal manner. So it's a feature. You are getting a personal coach, okay, personal expert who is guiding you throughout your preparation every moment, all right. And your test analysis will be done in a personalized manner. Your personal feedback will be given to improve your time management and exam approach, all right. Study planner will be in a customized way. So study planner, weekly reviews, all right. So to highlight your progress, everything will be given to you. Now you can download this Unacademy's Learning app from Play Store. You can download this Unacademy's Learning app from Play Store and start your journey with Unacademy. So let's start functions today, our topic. So we are going to do range. I'll tell you how to find the range. One minute, we are starting. All right, let's begin then. Okay, so see how to find the range. First, I'll tell you some concepts and slowly we'll um, do the examples. So first, I guess, range. First of all, what is range of a function? So if you write y is equal to fx, what was domain? Domain was values of x for which fx is real. So here, range is range of fx is the set of values of y for which x is real. All right, for which x is real. So if you real x, good evening, Siddharth. If I have not forgotten your name, Siddharth. Yeah. So range is a set of real values of y for which x is real. All right. So just like for example, if you need to find the range of y is equal to fx, then what you do? So you just write x in terms of y and then find the values of y for which this is real. Okay, this is a very basic method. So like y is equal to, say, I have written 1 upon x minus 1. Okay, so domain you can write easily, but if you need to find the range, then write x minus 1 is equal to 1 upon y, and then you can write x is equal to 1 plus 1 upon y. Now you can see what are the values of y for which x is real. So you can say y belongs to all real numbers except 0. So that will be the range. But in every case, this is not possible to do. In every case, you won't be able to find x so easily. All right, in terms of y. So we need to use other methods also. This is a very basic method. All right. So what is the other method? Like I'll remind you some important points about trigonometric expressions first of all. So we'll keep doing that, and then I'll generalize. Then I'll tell you a general method, which is applicable in most of the questions. So like you remember range of some important range of some important expressions. Like a square tan square theta plus b square cot square theta, or x you can write. When theta is a variable, right? Theta is a variable. So using AMGM, if you remember, its minimum value was 2ab, right? 2ab if a and b are positive, or 2 mod ab, 2 mod ab you can say. So range of this is basically 2ab to infinity, all right, where ab is a positive number. This was the range of a square tan square theta plus b square cot square theta. How did we find it? So I'm telling you the method using AMGM, okay, using arithmetic mean, geometric mean, inequality. we can find it, right? So this was an important expression. Suppose you need to find the range of a square sec square theta plus b square cosec square theta. This is very important again. In many chapters, you get this expression. So what you do in this case, you write it in terms of tan and cot. So a square plus b square plus a square tan square theta plus b square cot square theta. That means you know the range of this is 2ab to infinity. So range of this whole expression will be a square plus b square. So now I can write the range. Range will start from a square plus b square plus 2ab, okay, to infinity. That means range of this will be a plus b the whole square to infinity. So that is the range of this particular expression. Now another trigonometric expression is very important. This is a sine theta plus b cos theta plus c, right? Remember that? So how to find the range of this expression? Range of this expression. So if you remember, a sine theta plus b cos theta, all right, is always less than equal to under root of a square plus b square, right? And greater than or equal to minus under root of a square plus b square. We use this, all right? So whenever you have trigonometric expressions, we use these two particular inequality range expressions of range. So this will be the range. So what is the range of this? Range of this I can write minus under root of a square plus b square plus c to plus under root of a square plus b square plus c. All right, that is going to be the range. So I hope it is clear. Like for example, if you have find the range of fx is equal to 4 cos square theta plus 6 sine theta cos theta plus 8 sine square plus say plus 10 sine square theta minus 5. Can you try this? What is the range of this expression function? You can write f of theta because we are using the variable theta. So theta is a variable. Try this one. Getting something? minus 2 to 0. Okay, let's check. So I'll write this expression. You can write first of all 4 cos square plus 4 sine square as 4. All right. Then your 6 sine square will be remaining. Yeah, 6 sine square. Yeah. Plus 6 sine theta cos theta minus 5. Now what you need to do, convert this into 2 theta and this also into 2 theta. This will be into cos 2 theta and this will be in terms of sine 2 theta. So 4 plus 6, 2 sine square theta is 3 times of 1 minus cos 2 theta. You can write 2 sine square theta. Plus this is going to be your 3 times of sine 2 theta minus 5. Now you can see, you collect all the constants. So 3, 4, 7, 7 minus 5 is 2. So 2 and plus 3 sine 2 theta minus 3 cos 2 theta. All right. So using this formula, now you can apply. Okay. So whether you have theta or 2 theta or 3 theta, it should be same in cos and sine. Okay. So this angle should be same and it should be a linear expression of sine and cos. All right. We have got a linear expression of sine and cos. So its range is going to be minus under root of 3 square plus 3 square plus 2 to plus under root of 3 square plus 3 square plus 2. All right. So that is going to be the range. So range of f theta or y is this. This is 3 root 2. So 2 minus 3 root 2 to 2 plus 3 root 2. All right. This is the range. In this way we can apply. So I hope it is clear. Got it? Now I'll tell you another concept. So today we will cover all the basic points. See, if range of fx is a to b, all right, range of fx is a to b, then range of 1 upon fx. How to find the range of reciprocal of a function? See, that means if fx given that fx is greater than or equal to a and less than or equal to b, okay, provided a and b are not 0, I'm just assuming it. 1 upon f, you can write 1 upon f will be greater than or equal to b and less than or equal to 1 upon a. So when you take the reciprocal, the sign of inequality reverses. So how to write the answer? That is an important point. You can always write like this, irrespective of whether a and b are positive or negative or of opposite signs. Okay, you can always do that. Whenever you need to take the reciprocal, just reverse the inequality, both sides. All right. Okay, I'll tell you some examples. Suppose your, for example, your x belongs to x is greater than or equal to 2 and less than or equal to 4. Then what is your 1 upon x? So 1 upon x will be greater than or equal to 1 by 2 and less than or equal to, greater than or equal to 1 by 4 and less than or equal to 1 by 2. So that means your 1 upon x belongs to 1 by 4 to 1 by 2. I don't think there's any problem in this. All right. Now, second example is if your x belongs to x is greater than or equal to minus 4 to minus 2, entirely negative, right? Again, there's no problem. You can just take the reciprocal. So 1 upon x is greater than or equal to minus 1 by 2 and less than or equal to minus 1 by 4. So perfect. So that means 1 upon x belongs to minus 1 by 2 to minus 1 by 4. Okay. Yeah, perfect. Okay. So far so good. Now suppose you have third example. Your x belongs to say minus 2 to 4, positive to some negative number. All right. So you can see 0 is included in this. No problem in that. You can always write like this, which I have just told you. 1 upon x will be greater than or equal to 1 by 4 and less than or equal to minus 1 by 2. All right. Like this. And then how to write the answer in this case. Okay. Now that is an important point in this third example. So now read this like 1 upon x is greater than 1 by 4 and less than 1 by minus 1 by 2 is wrong. Okay. It is greater than 1 by 4 or less than minus 1 by 2 because you have two intervals, minus 2 to 0, minus 2 to 0 and 0 to 4. So reciprocals of 0 to 4 will be 1 by 4 to infinity. Okay. So reciprocal of positive numbers will be positive interval, and reciprocal of negative numbers will be negative interval. Okay. So this, so far it is correct, absolutely right. Now to read this, you need to read this as 1 upon x is greater than equal to 1 by 4, or so far we were reading like and greater than this and less than this. Now in this you need to read it like it is greater than 1 by 4 or less than minus 1 by 2. So that is the correct way. That's it. Done. So it is greater than 1 by 4, that means 1 by 4 to infinity. All right. Or less than minus 1 by 2, that means minus infinity to minus 1 by 2. And perfect. That is the answer. So in this we can find the range of reciprocal of a function if you know the range of some function. For example, let me give you another example. Say fx is equal to 1 upon okay, so 3 sine 2x minus 8 cos square x. All right. Plus 7. Try to find the range of this. Okay, where? Okay. I'll correct it. Yeah, that is 1 upon b. Thank you. That will be 1 upon b. All right, so you got it. Okay, try this one. Let me know the answer if you are able to do it. Okay. Yeah, Siddharth, are you trying this? All right, try it. Oh, once you have given minus infinity to minus 1 by 2 and 1 by 8 to infinity. Okay, we'll check. Let's Siddharth also answer. Then we will discuss it. Okay, meanwhile, I'm starting it. You let me know if you get your answer. So in this case, this is like a previous question. You can see it as angle is 2x here. An expression is of sine and cos. So if it is a quadratic in sine and cos, you can convert into double angle. Okay, cos 2 theta. So cos square can be written, 2 cos square can be written as 1 plus cos 2 theta. This is already sine 2 theta. So perfect. It will be linear in sine and cos. And angle will be 2x. So angle, whether angle is 2x or 3x, it doesn't matter. So you start with this 3 sine 2x. First write the range of this minus 4 times of 2 cos square can be written as 1 plus cos 2x. All right, plus 7. So you can write like this 3 sine 2x minus 4 cos 2x, and now it's going to be 7 minus 4 is plus 3. All right, so that's plus 3. Okay, now you can write the range of this. Its range is, this expression is greater than or equal to minus under root of 3 square plus 4 square, so that is minus 5, and greater than or equal to plus 5. Now you need to add plus 3, so add plus 3 in this and add plus 3 in this. All right, good, perfect. Your answer seems correct. Now you will get like this 3 sine 2x minus 4 cos 2x plus 3 is less than or equal to 8 and greater than or equal to minus 2. Now you need to take reciprocal of this. Okay, so reciprocal of this is nothing but 1 upon 3 sine 2x minus 4 cos 2x plus 3. All right, when you take the reciprocal, inequalities will be reversed. It will be 1 upon 8 and that will be greater than or equal to minus 1 by 2. So your answer, this is your fx. All right, so fx belongs to, what is this interval? 1 by 8 greater than 1 by 8 or less than or equal to minus 1 by 2. So your answer will be minus infinity to minus 1 by 2. Okay, union, that is going to be 1 by 8 to infinity. Perfect, perfect, very nice. Okay, got it, Siddharth? You have got it. This is a way to take the reciprocal. So I hope you understood. Okay, so any expression whose range you can find, you can also find the range of its reciprocal. Now I'll tell you one very important concept, okay, which we use to find the range of most of the questions. What is this concept? See, this concept is, if, suppose if f is an increasing function for all x belonging to x1 to x2. Okay, if fx is an increasing function for all x belonging to x1 to x2, that means for x greater than equal to x1 less than equal to x2, f is like this. Okay, increasing function. Say this is your x and this is your y. So this point is x1 and this point is x2. Then you can find the range of fx easily. Just put f function to all the points. Okay, you can write the range of x first, which is x1 to x2. Then you can apply f function. If f is increasing, you can put f function. F should be defined, so it is given that f is increasing in this interval. So you can put f function on x1, f on x, and f on x2. So simple. So range of fx is nothing but, you can directly write range of fx is nothing but f of x1 to f of x2. This you can do whenever you are applying an increasing function. You can see you will get the minimum value as f of x1, which will be at x is equal to x1, and maximum value at x is equal to x2, which is f of x2, and you will get all the points in between f of x1 and f of x2 if function is continuously increasing. So it's a continuous function, it is given. Then you can write this range. Okay, so this is for increasing function. So whenever you have the range of x, you can find the range of fx if f is increasing function, And this concept is very, very important. We use this concept in most of the questions. Okay, so I'll tell you the examples right after this. Now the second point is f is decreasing. Then what will happen? If f is a decreasing function, f is a decreasing function for all x belonging to x1 to x2, then what will be the range? See, in this case, you write f x is greater than equal to x1 and less than equal to x2. This is the range of x. Then, while putting this decreasing function f, inequality will be reversed. Inequality will be reversed. So that is the important, that is the main difference, f of x2. Because in this case, graph will be like this, decreasing, okay, decreasing. So you'll get the minimum value for the maximum x, which is x2, and maximum value at x1, all right. So range will be f of x2 to f of x1. I hope you have got it, all right. So whenever you are putting a decreasing function in inequality, inequality will reverse, all right. Whenever you are putting an increasing function, inequality will not reverse. So these are the very, very important concepts to use to find the range. I'll give you some examples. First of all, do you know how many functions do you know which are increasing? Like log function at base 1 whose base is more than 1. This is an increasing function. Just let me remind you some functions. If you have a log function whose base is less than 1 and more than 0, this is a decreasing function. Okay, this is a decreasing function. So you need to remember all these functions which are increasing and decreasing. If you have a raised to x, a is more than 1, it's an increasing function, all right. If you have a raised to x, a is less than 1 and more than 0, this is a decreasing function, all right. If you have sine inverse x, do you know sine inverse x? Sine inverse x is an increasing function. All inverse trigonometric functions are either increasing or decreasing. Yes, x cube, very good. So cos inverse x is a decreasing function, all right. We'll use that. So let me write the inverse trigonometric function. Tan inverse x is an increasing function, always increasing. This is increasing in -1 to 1. This is decreasing in -1 to 1. But tan inverse is always increasing. Cot inverse. So just assume that whatever I'm saying, I'm saying in the domain of these functions, all right. Cot inverse is always decreasing. Yes, so x raised to, if I generalize this example which you have given, Siddharth, then I'll say x raised to 2n plus 1, all right, with positive coefficient. A is positive, all right. This is always increasing function. And if I write a x raised to 2n plus 1, a is negative, then this will become decreasing, like minus x cube, minus 2x cube, all right. These are decreasing functions. Under root of x, this is an increasing function, all right. In fact, let's not say under root of x. In fact, any function x raised to n, where n is a positive integer, n is what should I say? Okay, let's write 1 upon n. Okay, 1 upon n, that's better. If I write x raised to 1 upon n, where n 1 upon n is less than 1, obviously n is an integer, you say, positive integer, like 1 by 2, 1 by 3, 1 by 4. Domain will change. Domain of x raised to 1 by 3 is all real numbers. So if you're taking x raised to, when n is odd, domain will be all real numbers. If n is even, then graph will be only in 0 to infinity, but it will be increasing always. Okay, so these are some functions which we are going to put without any hesitation, all right. I hope it is clear. Now let's see some example. Suppose we need to find the range of log of very, very easy example, x square plus 2 to the base 2, all right. We need to find the range of this function. So how do we start? Always whenever it's a composite function, f of g of h of x, always start with a function which is in the, innermost function, you can say. So we'll start with this function, okay. We'll start with this function. We know we can find the range of this x square plus 2 easily, right? So what is the right range of this function? So range of this function is x 2 to infinity, right? 2 to infinity, like this. Now this function has log outside, right? So now we need to put log function. And how's this log function at base 2? We have just learned that it is an increasing function, right? It's an increasing function, so we can put log. The only thing which we need to remember is while putting the log, these points, okay, this whole interval should be in the domain. If this interval is not in the domain, then you can leave those points which are outside the domain. Okay, so I'll tell you that in the next example. So while putting the log, you can put log of 2 base 2, that is log of x square plus 2 base 2 easily, and that is log of infinity. And we have got the answer. So this is your fx, log of infinity is infinity, and this is log 2 base 2 is 1. So range of fx is nothing but 1 to infinity. I hope you have got it. No problem. Now let's see second example. So suppose it would have been log of say x square plus 2 to the base 1 by 2 and to the base 3. All right. So now you can see we have three functions in composition. Log of x square plus 2. Okay. Base of this outer log is 3 and base of this log is 1 by 2. So again, we'll start with the same point. X square plus 2. Okay, we have just written it as, so I'm telling you the concept. All right. So x square plus 2 will start from 2. I hope it is clear. There's no doubt about it. To infinity. Infinity is open always. Okay. Now we need to put this function. Okay. Second function, which is log at base 1 by 2. But log at base 1 by 2 is a decreasing function. You know that? I just told you if base is less than 1, then it is a decreasing function. So put that log, but make sure, because it's a decreasing function, so you need to change the inequality. You can put log on these in this interval 2 to infinity. It's entirely positive interval. So this log of x square plus 2 to the base 1 by 2. It is log of infinity to the base 1 by 2. Log of infinity to the base 1 by 2 is basically minus infinity, right? It's a decreasing function like this. So for x approaching to infinity, you'll get minus infinity, right? What is this value, by the way? Log of 2 base 1 by 2. This is also negative. This is minus 1, right? So this interval is minus, oh. So you have got entirely negative interval. Wow. Entirely negative interval. So log of, this is minus infinity. Now because this interval is entirely negative, so no value will go. You can't put this log on a negative interval, right? That means there's no point in the range. Okay, there's no point in the range. I hope you have got this point. Okay, because if this is giving all the negative values, then this outer log will not be defined for those values. That means there won't be any outcome of this fx function. So no range, or you can say range is phi. Range is phi. Okay, I hope you have got this point. Any doubt, Siddharth, Vamsi? I'll tell you another example. Okay, I'll give it to you to solve it. You solve it. You guys solve it. Range. You need to find the range of log of x square plus 4x plus say 14, then base 10, then base 1 by 2. All right. Find the range of this. Find the range of this. Yeah, null set. Perfect, Siddharth. Try to find the range of this. Hmm. Getting anything, guys? Okay, so you're getting the all negative real, Vamsi, and Siddharth is getting all real numbers. Let's see. If I start with this function, okay, we'll start the function which is the innermost function. So I can write x square plus 4x plus 14. Whenever it is a quadratic, you can write it as a perfect square. So x plus 2 the whole square plus 10, right? So now I can write that x plus 2 the whole square plus 10 is always greater than equal to 10 and less than infinity. Minimum value will be 10. Perfect. This can be 0. So 10 to infinity. Now you need to put this log. So put this log base 10. So it is an increasing function. You can put this log, no problem. Entirely positive interval, so no problem in putting log. So this will be x square plus 4x plus 14 as it is. And base 10. This is log of infinity base 10. This is going to be now 1 is less than equal to this log function, log of x square plus 4x plus 14. Log 10 base 10 is 1, and this will be infinity only, right? Now we need to put which function? Again a log function, okay? Again a log function, but this log function is of base 1 by 2, okay? You can put this log function because this interval is entirely positive interval, so you can put, okay, log, but inequalities will be reversed, all right? Remember that. So log of 1 base 1 by 2 is more than equal to, because this log is decreasing function, this log is an increasing function, right? And then log of x square plus 4x plus 14, all right? And this was base 10, this was base 1 by 2, and greater than log of infinity base 1 by 2. So what is this value? I'll write it here. So the least value is minus infinity, is less than your fx, all right, is less than log of 1 is always 0 at any base, all right? So yes, it is entirely negative. Your answer is right, Vamsi, including 0. I hope you were including 0 in your answer. Siddharth, have you got it? Got your mistake? It is not all real numbers. It is all negative real numbers. Or you can say non-positive real numbers. It's a better way of saying it. That will include 0 also. Non-positive. All right. So I find the range of this another function. This one. What is that log? 9. This base is 9. This base is 9. Okay, I'm creating some space. Okay, so this is another question. Have you got anything? 1, 3, you got 5/6, 2, 5/2. All right, Siddharth, are you getting anything? Okay, then let me discuss. Again, it's a normal usual quadratic. So let's start with this quadratic, okay? By making it a perfect square, I can write this can be written as x minus 1 the whole square, x square minus 2x plus 1 and plus 3, all right? So x minus 1 the whole square plus 3. So that is greater than equal to 3, or you can apply the formula minus d by 4a to infinity. Then you can apply this log function at base 9. So increasing function can put this log. So log of this 3 base 9 is less than equal to log of x minus 1 the whole square plus 3 base 9 and log of infinity base 9. All right. Then you need to write this function is going to be between, so log of this x square minus 2x plus 3 base 9 is less than infinity and greater than equal to, this is nothing but, you can write 1 by 2. Yeah, 1 by 2. 1 by 2, okay? So 1 by 2 to infinity. Now you need to put sine inverse, but now this is an important point. When you're putting sine inverse, then you need to put on, you can put sine inverse only on the values which lie between -1 and 1. So whatever values in this, in the range of log, are outside 1 or less than -1, you can remove those values, all right? So you can see this is going up to infinity, starting from 1 by 2. So you can start from 1 by 2 and write up to 1 only, okay? 1. That's it. Log of x square minus 2x. Then you can put sine inverse. So now you put sine inverse. It's an increasing function. So sine inverse of this, sine inverse of this, and here it is going to be sine inverse of 1. Okay? Sine inverse of 1. I hope you have got this point. Sine inverse of 1. So all those values in range of log function which are outside the domain of sine inverse, you need to leave those values, all right? You need to leave those values. Just write only those values which lie in the interval of outer function, which is sine inverse in this case. Okay, now that's it, done. So sine inverse of pi by 2 is nothing but, yes, pi by 6 is less than equal to, this is your fx, less than equal to, this is your pi by 2. Yeah, perfect. Correct answer. Now we have one last sum, this one. So you guys try it and we'll end with this. All right. Try this particular sum. Got it? Vamsi, your answer is correct. Siddharth, have you got it? Are you learning something, Siddharth? Okay, so this is the fractional part. I'll read this function, this under root of sine of tan inverse of log of fractional part of x. Oh, okay. Do it properly, this one. It's okay if you do mistake, but do not repeat it, okay? The same mistake you should not repeat it. Just remember that. Try to practice that only. Any answers? I'll give you some options. A option, uh, 0 to 1 closed. B option is -1 to 1. C option is 0 to 1 closed open, and D option is 0 to 1 open. Not right to answer it. Hello, hello. What's your name? Heartbeats. Okay, so you're getting A and Vamsi is getting D. All right, let's check. I'll start with the fractional part function. So fractional part of x we all know is between 0 and 1. Now we need to put log, but we can't put log on 0. So that means we need to remove 0. All right, so no problem because 0 is not in the domain. So remove 0 from the range of fractional part and put the log on the remaining function, remaining values. So if you put log, this is basically 0 plus, right? The log of 0 plus to the base 1 by 2, and log is a decreasing function. So inequality will reverse. You can see this base is 1 by 2. So it's a decreasing function, all right? So fractional part of x base 1 by 2 is greater than log of 1 base 1 by 2. All right, Krishna. Uh, then you need to put tan inverse, all right? So you put tan inverse. This is going to be log of 1 is basically what? Log of 1 is 0, and this is inequality. See, there's no equality, all right? This is infinity. Log of 0 plus at base, because graph is like this, right? Log of graph of log is like this. So you had 0 to 1, so you got the range of log from 0 to infinity, right? Now you need to put which function? You need to put tan inverse. So put tan inverse, it's an increasing function. There's no problem in putting tan inverse. So tan inverse of this and tan inverse of this. So what is the value of tan inverse 0? That is 0. And what is the value of tan inverse infinity? It is pi by 2, right? And that will be tan inverse of log of fractional part of x to the base 1 by 2. Now the last function. Okay, so it's all right. Now you have got this whole thing is a theta, right? You need to find sine theta. It's very easy. So if theta is 0 to pi by 2, what is sine theta? Sine theta is an increasing function in 0 to pi by 2. So your answer is going to be sine of 0, sine of this, because sine is increasing in 0 to pi by 2. That's why I'm putting sine function. Sine x is increasing when x belongs to 0 to pi by 2. So yes, of course you can put sine in this inequality, all right? So this is going to be 0 and this is going to be 1. So equality will not be there. Have you got this point? It was a very good question. The only confusion was this equality. Equalities are not there. Got it? Again, a mistake, Siddharth. So we will continue doing questions based on range in our next session tomorrow. All right. So tomorrow we'll continue range. We'll discuss a lot of good problems again on remaining concepts. Krishna, where are you from? Which class? Chalo. All right, guys. Take care. Good night. Good night. Good night, everyone. Thank you. Bye bye.